Okay, so let us discuss today on divided differences. Okay, previously we have seen forward difference and backward difference, and these differences belongs to equidistant data. Okay, that means between each consecutive x, you will be having common difference will be there. Correct. So common difference like h we have found in each and every problem. If you see the previous problems, 40, 50, 60, 70, 80 is there. So this is an equidistant data. Similarly, all x, 40 next. Here also 80, 85, 90, 95, 100. Common difference is here h. Okay, what happens if data is not equidistant? Okay, that means if you don't find any common difference, so what we need to do? Okay, so there you'll get the answer. We have divided differences. Okay, so for random data, we can make use of divided differences. Okay, so let us see what is these divided differences. Let f of x naught, f of x1, f of x2, and f of xn be the values of unknowns, okay, of the function y is equal to f of x corresponding to the values of x, where x represents set of data, that means x naught, x1, x2 up to xn, which are at unequal intervals. Okay, previously we have taken in forward difference and backward difference, we have taken equal distant data, equal interval data. Okay, they'll be having some common difference, but here there is no common difference. Okay, so then the first order divided difference are defined as follows. Okay, how will you define that? Means f of x naught comma x1, suppose you are taking difference between these two variables. Okay, then what we need to do is take the second value, second ordinate of this pair, that means f of x1 minus first ordinate, that means x naught. So f of x1 minus f of x naught divided by x1 minus x naught. Similarly, if you take this pair x1 comma x2, then you'll get f of x2, that means second ordinate minus first ordinate function divided by x2 minus x1, second ordinate minus first ordinate. Similarly, in the same way, you can write like n number of times. Okay, so what happens in second order difference? Okay, when you are taking second order difference, first take last pair. Okay, first take last pair. What is the last pair? x1, x2 minus first pair. Okay, so f of x1 comma x2 minus f of x naught comma x1 divided by last number minus first number. Okay, so let us see one example based on this, so that we will come to know. It's about general principle. Okay, so by observing this, can anyone tell what is the divided difference of f of x3, x4, x5? How to write the
f of
divided
x4
difference?
minus f of
F of
x4,
mm,
x4 comma x5
yes,
minus
mm,
f of x3 comma x4
yes. Next,
divided by
mm,
x5 minus x3.
x5 minus x3. Yes, like this. Okay. So suppose if I am having f of x2, x3, x4, x5. Four values are there. Four values are there means how to find? Here three values are there means we have used second order divided difference. Here I am using four variables. That means third order divided difference we need to use. In third order also you have same. In third order also you need to do in the same way. Can anyone tell how to define fourth order difference? Difference between third orders. Take last
F
triple.
of x3,
Okay.
x4, x5
Yes. F of x3, x4,
x4, x5,
x5
x5
minus
minus f of x2, x3, x4
x2, x3, x4
minus
divided by
divided by x5 minus x.
x5 minus x2. That means last number minus first number. So in the same way. Similarly, can anyone define f of x7, x8, x9, x10? This is also fourth order difference.
F of x8, x9, x10
8, x9, x10.
minus
mm,
f of x7, x8, x9
is divided by
x9 minus x7,
mhm,
x10 minus x7.
is x10 minus x7. That's it. Are you getting how to write divided differences?
Yes,
So
sir.
once you understand these differences, we will form the table like previous forward difference table we used to run, right? So like that we will fill the table by using this divided difference, and we will follow this interpolation formula. This is having own interpolation formula that is called Newton's general interpolation formula. Okay. Previous those two formulas are Newton's forward interpolation, Newton's backward interpolation. This is Newton's generalized interpolation formula. Okay. So for this, no need of any equidistant data. Okay. No need of equal interval data for this. Okay. So let us see what is this. If f of x naught x1, f of x2 up to f of xn are the set of values of an unknown function f of x corresponding to the values x0, x1, x2, x2 up to xn, which is an at unequal intervals, then y equal to f of x, which is defined as f of x naught x minus x naught into f of x naught comma x1. Similarly, x minus x naught into x minus x1. Okay, so this will continue. X minus x naught will be transferred for all the terms, and along with that, one more term will be added, x minus x1. Okay, f of x naught, x1, x2. So third order difference. Next, we'll go for fourth order difference. Like that, it will continue up to 10th order difference. Fine. So if you take one example, we'll come to know. Wait a minute. Yes. Now, here they have given construct the interpolation polynomial for the data given below using Newton's generalized
Sir,
interpolation formula.
sir,
Yes.
we can't see the screen, sir.
Oh, wait a minute. Now,
Yes, sir.
okay. So here construct the interpolation polynomial. Okay. He is not asking any value. He is asking, I want the equation of the data which follows this table. Okay. So what he is asking exactly is, he has given some set of values of x and corresponding function values. We don't know about function. Okay. Now using this data, he is asking us to find the polynomial. So what kind of polynomial we have used to get this data? Okay, this is our main point. So finally, output of this data, you result in polynomial. Okay. So for that sake, what we need to do, we have to make use of Newton's generalized interpolation formula. Okay. So let us see. First, we need to draw Newton's divided difference table. Okay. For that sake, write this in column wise, like x equal to 2. Okay. X equal to 2 I have taken. 4, 5, 6, 8 and 10. Corresponding y values I have taken. Okay. So once you take this data, start doing forward difference table. Okay. That means Newton's first order difference table. So if you take first two elements, previously we used to subtract only second value minus first value. Okay. But now along with this, second value minus first value divided by second x value minus first x value. Clear? So 96 minus 10 divided by what is the corresponding x value for? Minus 2. Okay. So if you do that, you will get 43. Next, I have taken this data. 196 minus 96. Okay. Along with that, corresponding x values also you have to subtract and divide. Okay. So 196 minus 96 is how much? 100. 100 by 5 minus 4, 1. So 100 by 1, it is 100. And it is denoted by first difference is f of x naught comma x1. Second one is x1 comma x2, because these are the values of x0, x1, x2, x3, x4, x5. Here also f of x0, f of x1, f of x2. We have done the difference between f of x2 minus f of x1. So that is defined as f of x1 comma x2. Similarly, what is the next difference? F of x3 minus f of x2. That means f of x2 comma x3. And it is defined as 350 minus 196 divided by 6 minus 5. So that is 154. Okay. Similarly, 8 minus 6. How much? 8 minus 6 is 2. 868 minus 350. So overall, if you divide 259, you will get. Okay. So if you observe between x, what is the difference between first value? 4 minus 2. It is 2. But what is the difference between second pair? 5 minus 4, 1. Here 2 is there. Next, here 1 is there. Next, here difference is 2. Here difference is 2. So here The data is random. Okay, it is not followed one particular difference. So when the data is given like this, we can make use of Newton's divided difference, and I have calculated first order difference also. Okay, so now go to second order difference. Second order difference is between these two, next to these two, next to these two, next to these two. Okay, so you are dealing with f of x1 comma x2. Suppose let us write here f of x1 comma x2 minus f of x0 comma x1 divided by uh, here what is there, x2 minus x0 is there. So how will you define? Yes, how to define this? Previously, I used to ask like this, right? F of x1, x2, x3. But now I am asking in reverse way.
F
Yes,
of x1, f of x naught, x1, x2.
x0, x1, x2. Nothing. Just you need to observe what and all the different variables are available in this. That's it. And write it in order. So here x0 is there, x1 is there, x2 is there. So write like that. That's it. Okay. Similarly, take the next difference. What is the next difference? We have taken f of x2 comma x3 minus f of x1 comma x2 divided by x3 minus x1. This is nothing but f of what and all the variables available here. Write it in order. This one is x1, x2, x3. That's it. Fine. So third order difference we have calculated there like this. So now this is main part. 154 minus 100 you have taken. Here we need to observe what is the last variable here, x3. Here x2 is there. So that means x3, 6 minus, what is the least value here, 4. So 6 minus 4 you have to take. Yeah. Similarly, while taking the difference between 259 minus 154, what is the least value and highest value you have to take? X2 is the least value and x4 is the highest value. So 259 minus 154. So here x value, corresponding x value is x4 minus x2. So that means 8 minus 5 you have to take. Clear?
Yes, sir.
So 8 minus 5 I have taken here. Similarly, when you are taking difference between these two, so what is the least value? It is x3. So that means this. Highest value is x5. So 439 minus 259 divided by 10 minus 6. So difference between these two. Clear? Next, go for third order difference. This will be this much. 27 minus 19. Okay, 27 minus 19 means here last value is how much corresponding? This value is there. Give two gaps. Last one. That means 6 minus 2 you have to take. Clear? Similarly, draw a line like this. After writing this, which value will be available? That value you have to take. Next, here last value. In this line, what is the last value? Diagonally. X1 is there. So, 8 minus 1. That means 4. 8 minus 4 will get. Clear? Similarly, if I take this one, in this diagonal, what is the x value? You have to check. Next, towards here, draw a triangle. Whatever the corner number you will get, that number you have to select. So that means 10 minus 5 you will get. So here 10 minus 5. Clear? So after forming all the table values, then we'll go for interpolation polynomial. Okay. Interpolation polynomial is nothing but f of x is equal to x naught, f of x naught, x minus x naught into f of x naught comma x1, x minus x naught into x minus x1, f of x naught, x1, x2. Similarly, three terms until we are having third order difference. So up to third term it is enough. Okay, so substitute it. F of x is equal to f of x naught. F of x naught is 10 here. Next, x minus x naught. X minus x naught is 2 into first order difference. That is 43. X minus x naught into x minus x1. X minus x1 is 4 into second order difference. 19. Next, x minus x naught, x minus x1, x minus x2 into third order difference, that is this one. Clear? So if you observe this also, this is followed in a diagonal form. Like first this one. What? Forward difference or backward difference. We'll use to write one diagonal line, right? So here also it follow the same thing. Fine. So after that, just we have calculated this and simplified. Finally, we got the polynomial as this much. Check with this. Here he is asking, using Newton's divided formula, find the polynomial for this. Sorry, he is asking the values. We need to find these values in this problem. Find f of 8 and f of 15 he is asking. F of 8 and f of 15. Okay. So first stage is write the table. First column should be x values, second column should be y values or function of x values. Okay, I have written like this. Next, form the difference. So first order difference is this. Difference between these two, difference between x values. So divide both the values. Similarly, divide difference. Okay, 294 minus 100 divided by difference between these two. Next, difference between these two divided by difference between these two. Difference between these two divided by difference between these two. Difference between these two divided by difference between these two. So you'll get finally as 52, 97, 220, 202, 310 and 409. Okay, once you got all these values, go for second order difference. This time we have to take difference between these two. You draw one diagonal line to this. Which x value you'll get, that x value you have to take first. Next, draw diagonal line in this direction, top direction and front direction. Which x value you'll get, so this value you'll get. So you go for 4. So difference between these two divided by diagonal values of x. Okay, so 7 minus 4 you got. Similarly, take difference between these two. Okay, what are the diagonal numbers for this? Maximum. This is there and this is there. So 10 minus 5. Clear? Next, difference between these two. 310 divided by 202. So what is the x value here? Next, what is the x value here? Sorry. This one you are taking, right? So for this one is there and this one is there. 11 minus 7. Next, for this also you take this value and this value. Okay. So 13 minus 10. Next, third order difference. So take the difference between these two. Okay. Just count the values from starting onwards. How many values we have taken? Maximum up to 3. Okay. So x0, x1, x2, x3. Okay. What is this order? Third order. So third order means last number in middle, two gap, first number. Okay. So 10 minus 4 you have to take. So 10 minus 4. Next, difference between 27 and 21. So next four numbers. What are the next four numbers? This. So last number minus first number. Clear? Next, after that, next four numbers. So these are the next four numbers. Last number minus first number. Okay. So you'll get 1, 1, 1 as the difference. Next, if you take difference between these two, you'll get 0, 0. So we'll stop at fourth order difference. Like previous table, it will be there. Next, once you write all the differences, what we need to do? Find the polynomial like this. Okay. So make use of this formula. F of x naught x minus x naught into f of x naught comma x1 plus x minus x naught into x minus x1 f of x naught comma x1 comma x2. Like that it will continue. Okay, I have substituted. First number is f of x naught, that is 48, into x minus x naught. X minus x naught is 4, into first order difference, it is 52. Next, x minus 4, that means x minus x naught into x minus 5 into 15. So like that you will get. Once you get the polynomial here, if you simplify this, you will get this much. Substitute x value. That means f of 8 we need to find. So we need to find f of 8. But what is the polynomial here? X cube minus x square is there. So 8 cube minus 8 square. And how much? 8 cube. 8 square is 64. 64 into 8.
512.
512 minus 64. Get 448. So that only we have it. Okay. Next, similarly, f of 15 is nothing but 15 cube minus 15 square. 15 cube, 15 into 15, 225. 225 into 15.
3375.
So 3375 minus 15 square, 225. So we'll get almost
3150.
3150. That only we did. Fine. Very simple problem. Like forward difference, we'll finding in this method. Okay. So go through these problems. We have more examples in your textbook material, which I have shared in Google Classroom. Go through the remaining problems also. Okay. So in the next class, we'll continue with Lagrange's interpolation. This is Newton divided difference. Next, we'll go for Lagrange's interpolation. For that, no need of any table. Orally, we have to write. Clear? So let us see. Let me take the attendance for this class and go through the problem once again. If you have any doubts, let me know.